I'm going to invite Tim Kadlec up to the stage, and he's going to give a session on web performance.
Thanks. This one, yeah, that's good. Yeah, so I talked to the Botify folks. I think the incentive here is that if you manage to stick through this entire talk, that's how you get access to the happy hour. I haven't gotten final confirmation, but that's what I'm angling for. But before I start, though, I wanted to say, can we get a round of applause for Megan and Paul and the entire Catalyst team, because this has been fantastic. I have been so thoroughly impressed by the quality of the content, just the atmosphere. It's a very friendly, engaging area. It's been great. I'm a web performance consultant, so I do a lot of talks at web conferences, like web development, web design, performance, stuff like that. This is actually my first technical SEO event. It's my first SEO event, period. And I wasn't sure what to expect, but it really has been fantastic. And it's been amazing, and it's been great and wonderful and stellar and super and outstanding. Is that enough? That's enough keywords, right? I'm so sorry. I will say, I couldn't resist it. I will say for you to have some fire back at me. As a performance consultant, I get a lot of grief as well. I gave a talk at a company in Canada, and afterwards, the development team was kind enough to gift me with this poster that is now posted on my office wall. So yeah, I feel a lot of the same pain. It's fine. No, but I actually think that it's interesting, because I think, like, from an outsider perspective, I think SEO, and particularly the technical SEO side of things, has a really kind of pure and noble goal about it. My perspective is the goal of search engines, the goal of search engine optimization, is to help connect people with the information that they need in the highest quality source. And I think that's a pretty pure, ambitious goal. Like, that's a pretty noble endeavor to be undertaking. And particularly what interests me is that high quality source part of it. Search engines have gotten a lot more opinionated now about what constitutes a relevant and quality source of information. We've come a long way from the term frequency stuff that Frederick and Christy were talking about from 1957. It's nowhere near that, right? Like, we have everything factored in now, not just the content itself, but how that content is structured. We factor in how well that stuff is packaged up. Like, what is the design? Is it mobile friendly? Is it performant? All of these things kind of come into play. Performance in particular this year has been a hot topic of discussion. I've actually had several people that I've worked with this year that came specifically because an SEO consultant told them, hey, you need to improve the performance of your site, so thank you for that. It's also why I was very happy. I was a little nervous when the panel was up and somebody asked if, like, people from SEO are getting a little out of bounds with the performance stuff, and I was like, no, please. So I was happy to hear everybody kind of agreeing that this is right in the right wheelhouse. You know, this is nothing new. Like, 2010, I think, is when Google launched or first wrote about performance being in the search rankings in some way or another. At the time, it was desktop only, at least allegedly. Somewhat ironically, given that mobile performance can be so terrible, but that's where they started. But what kind of jumped it this year was at the beginning of the year, they talked about their speed update. And then in July, that rolled out, where finally, officially, performance is a part of the ranking consideration from a mobile perspective as well. And so this is what really has been drawing the attention to performance this year from an SEO perspective. We don't know what that metric is, though, that they're looking at. We don't know much about how they're using it. We know that it factors in. We don't know what metric they're looking at. It could be anything. We don't know. You know, even the weight it carries. Like, is it a tiebreaker? Are there situations where it's more important than others? Like, is it more important on a mobile search than a desktop search? If they can detect that the network is slow, does that make performance a bigger part of the algorithm? All of that's kind of speculation. The only thing we really have is from, like, 2013, when Moz paired up with Zoomph to do a study on page performance, trying to find which metric had the highest correlation to search engine ranking. Now, to be clear, the conclusion of this isn't that the metric that they found is the one that Google was using. That's not what they were going for. They're just trying to find, again, that correlation to sort of get a hint. Interestingly, the metric that they discovered was time to first byte, which is probably the least likely candidate, in my opinion. Like, if anybody's not familiar, time to first byte measures the time from when I enter in the URL to when I get that first byte of content back from the server. That's it. It doesn't tell me anything about when the page displays, when the page becomes usable. It doesn't even tell me if I've got the entire HTML. All it tells me is I've got that first little itty-bitty chunk of it. It's a good metric for things like telling you that your server's running slow and you probably have some caching issues or you have CDN issues. But that's the extent of it. So consider, for example, the Boston Globe. Time to first byte on Boston Globe on a 3G network is 341 milliseconds. This is what the site looks like at 341 milliseconds in the loading process. There's not much there. Anybody feel confident from this single data point telling us if the Boston Globe performs well or not? Probably not. It doesn't give you a lot from a user perspective. It doesn't give you much information. So as an industry, we've sort of started to shift from this in the performance community. We keep tabs on it, and we keep tabs on load time, but they're not the primary metrics anymore. We're much more focused on metrics that matter to the user and answer questions that they have. So for example, once I type in a URL, when do I get some sort of signal that something's happening? So for that, we look at something like start render. On the Boston Globe, that's about 5.7 seconds. That's the point at which something appears on the screen. When is that stuff meaningful? When is it meaningful content? Now, Boston Globe has the exact same meaningful time as their initial render. 5.7 seconds is meaningful content. In some situations, your start render is like a background image or a background color, and that's not particularly meaningful. So you end up with a gap between start render and meaningful paint. But that's, so is it happening? Is it meaningful? And when can I actually use the thing? Like, when is the page interactive? For Boston Globe, that ended up being about 33 seconds on a 3G connection. This is because we have a lot of stuff in Cruft, and we'll talk about some of those things coming in, like third-party scripts and other things that slow it down. But this is the first point in the page load process where if I click on something, the browser is free enough to respond to it. Anything before that, and I'm clicking, the browser's just kind of waiting because it's too busy with everything else. These are much more meaningful metrics. And if you want to keep tabs on these, and I feel like you should, Lighthouse is a fantastic tool for this from Google. I know they've got the accessibility audits and SEO audits and a whole bunch of other things baked in as well. It's just a good thing to have running consistently and monitoring. But they'll report each of these metrics for you, so you can kind of keep tabs on how you're doing. But these are much more meaningful, much more impactful metrics. They're also notably the metrics that all the browser teams are pushing. Like Google Chrome team is very vocal about this. The Edge team is very vocal about this. The Firefox team is very vocal about this. The app team is pretty vocal about these metrics. Now, I'm not necessarily, I don't want to insinuate that the search engine team and the Chrome team, for example, are in cahoots here and they're pushing the metrics that the search engine team is also going to be focusing on. But I do think it's a signal that you can at least be kind of paying attention to. And if I was a betting man, which I'm not, but if I was a betting man, I would say that if they are not using signals like this right now, it's going to be happening in the near future. Again, search engines' goal with including performance is to make sure that they're ensuring a better experience for users when they click through. So it makes sense for them to focus on those user-focused metrics. We may never get the answer, and I hope that we do not, to be honest with you, because as soon as you start optimizing for an individual metric, the rest of the metrics kind of get pushed to the side. That's why it's usually good to have several metrics that you're looking at so that you're not, neglecting some of them in the process. There is no one metric to rule them all, especially when it comes to performance. It's like trying to measure how fast you're running a marathon by taking your 5-mile marker and extrapolating the data based on that. Like, you can't do it. It's a journey, and to measure a journey, you have to measure multiple stops along the way. You also don't just make performance faster for the sake of making things faster. That's not why we do things. We do it because we know that there's a business value. This is a chart from SpeedCurve, which is a great performance monitoring company, with a client that I worked on earlier this year. And what it's showing you is the bounce rate as it relates to start render time. So the start render time is here in the blue, and you can see that as the start render time gets higher and higher, that pink line, that bounce rate, continues to go through the roof. There's a direct connection here between how quickly we get stuff on the screen and whether or not those people are going to stick around. And this is far from an isolated incident. Tammy Everetts and I maintain a site called WPOstats.com where we collect every case study we've ever seen that ties performance to some sort of a key business metric. And there are pages and pages of these things here. And in fact, if you're ever working with someone or ever find your own stuff, particularly as it relates to SEO traffic kind of stuff, because we love that kind of thing, you're free to submit stuff on through GitHub and we pull it right in. But we've seen it impact every single major metric we can think of. Everything from bounce rate. Etsy saw a 12% increase in bounce rate just by including 160K of images on their mobile site. To engagement. This woman found that they had conversion jump of 50% by improving their load time. Tokopedia talked about how they reduced their start render time, and when they did, they saw engagement metrics across the board improve. And then yes, traffic. Pinterest rebuilt their pages for traffic and saw a 15% increase in SEO traffic. And they're not isolated. They're not the only example that we have from this either. We've seen a direct relationship. This is why we make things faster. This is why search engines, again, search engines don't prioritize performance for the sake of doing it. We don't make things faster for the sake of making them faster. We make things more performant because better performance means a better experience, and that means better revenue, better conversions, better engagement. So this means that we have a little bit of a challenge, though, because the web as we've built it, and I say we kind of collectively, not just us in this room, but developers, designers, everybody involved in it, is a bit heavy. Over the last 3 years, if you look at data from HTTP Archive, which monitors all sorts of information across 1.3 million different sites, you'll see that the median page weight has jumped by 15% on desktop and almost 50% on mobile. It's a huge jump. And does anybody want to take a guess? We've sort of alluded to it probably half a dozen times already today. Anybody want to take a guess which resource might be driving a lot of that growth? JavaScript. Yeah, JavaScript has been mentioned so many times in passing today, and always with like the rightful trepidation. Yeah, JavaScript is pushing a lot of this growth. As developers are sort of latching onto these client-side frameworks, things like React and Angular and Vue and Ember, you know, and these are fantastic from a developer ergonomic perspective. They're great. I mean, as a developer working with these, they're very friendly. It's very easy to build out some really complex, rich, immersive experiences with them. But the cost is that we're putting more and more JavaScript onto the device. So over that same 3-year span, JavaScript has increased by 55% on the median on desktop and a whopping 73% on mobile. We are using a lot of script to power these pages. And JavaScript introduces a big bottleneck both for search engines as well as for the browser itself. So from a search engine perspective, we talk about like the crawl, process, index, you know, sort of approach, right? And it's always been pretty straightforward. Like you do the crawl, you do some processing, you index a few things, you queue up a few more things for crawling. It's not bad. And if it's HTML content, this is still what it is. That's your first pass. It works great. Google's been very vocal this year about how much more involved this process step has gotten. Now they actually have to go through a whole rendering process inside of here. So you get that initial pass, and if your content's there, it's good. But then the second pass, what they have to do is they have to actually add these URLs to a renderer queue, and then take those URLs and one by one, probably not one by one, they probably have multiple servers, but you get the point. They start to pull things out of the queue, pass it to the renderer, which is basically a headless version of Chrome, running like 41, really old version. They should probably update that. And pass it through Chrome 41, and then that's your output. Like once they run the JavaScript, now they can actually look and index some of that content that's coming from those JavaScript-heavy pages. Bing has a very similar solution. The terminology is a little different, but they have like a crawl queue, and their renderer is based on Edge. But it's similar, right? You have to fire it up in the browser to render, to actually execute the JavaScript and render some content out so it's usable. Now, Bing and Google have done a lot of amazing work to make this process as fast as possible. In fact, Frederick, I think, has given a talk about all the work that went in from the Bing side of things to speed this process up. However, they do have the deck stacked against them a little bit. It turns out that there's, you know, a few like 100 trillion different URLs online, and it takes time to process that many URLs. And so it takes a while to go through the queue. So at Google I/O, it kind of there was a little bit of waves coming out of this, at least in the circles that I follow, when they revealed on stage that in their situation, it can take as long as a week for your URL to get through that queue. So if you've got a JavaScript-heavy page, yeah, Google can run some JavaScript. Bing can run some JavaScript. You can get those things indexed, but it might take a while before that happens. In the meantime, you've got new pages or new content or changes that's kind of just sitting there languishing. So there's a big bottleneck from search engine perspective. There's a big bottleneck from the browser perspective as well. When a browser finds JavaScript, it stops everything. So when it's coming along and it sees that you're using jQuery Acular, which is probably in production somewhere, a combination of these 3 libraries, what happens is the browser says, hold on, JavaScript can change the DOM, JavaScript can change the styles. I need to stop everything. I need to download the JavaScript. I need to parse it. I need to compile it, figure out what I'm going to do, execute it, and then I'll continue on parsing the rest of the page. So it is a huge bottleneck in the display of the page. Now, we can help it a little bit by giving it a few hints, and it's actually much easier than it used to be. It used to be you had to use some complex JavaScript to load all these things and handle it. Now, more or less, it's a little bit more straightforward. We have the async and defer attributes. So what async does is async says we're going to move the downloading part in parallel. So when the browser finds a script with an async attribute, it's going to go ahead and download that JavaScript while continuing to parse the rest of the HTML. And then only once that JavaScript's downloaded, we don't know when that's going to be, but once it's downloaded, it'll stop what it's doing, execute the JavaScript, and move on. So at least we move some of that in parallel and reduce the bottleneck a little bit. Defer is even better. Defer is sort of the nuclear option. With defer, what we're saying is defer the execution until everything else is done. So when it finds the script element, it doesn't stop. It just keeps going, parsing the HTML, downloading the JavaScript in the background. Once that HTML has all been parsed and we have an opportunity to actually get something on the screen, that's when we're going to execute the JavaScript. So defer and async can push a lot of this bottleneck stuff out of the way and get things out onto the screen much quicker. They also have the added advantage of making the page interactive a little bit earlier, like reducing the amount of work the browser has to do on the main thread. Browsers operate with this concept of threads. It's similar to like a department store, right? Think of a checkout line at a department store. Imagine, this is the worst designed department store ever. Imagine that they have one line that handles all the checkout, it handles the returns, it handles the customer service. You're all queuing up in the same queue, right? And it's not, if you've got like one thing you want to return, we've all been in that situation. You get one thing you want to return, and the person in front of you is like buying like $600, $700 worth of Legos or something, and it's slowing down the entire checkout process. They want to help you, and they will eventually get to you, but they have to take care of the rest of it first. This is how it works with like the main thread of the browser. The main thread of the browser is responsible for JavaScript execution. It's responsible for anything that the user does, responding to that. It's responsible for anything related to layout or painting. Anything like that happens on that main thread. So if we've got a lot of JavaScript running, it means if a user comes along and tries to interact with the page, the browser's it can't do anything until it's done with what it's trying to do. When we use async and defer, what we do is we tell the browser it's OK to put that on a separate thread. So just like a department store opens up multiple different lines for you so that you can kind of move through a little bit faster at least, the browser will try to open up multiple different threads. Now, it still has one main thread, right? Like at the end of the day, the user input, the layout, and the actual execution of the script all has to happen on this main thread. It's sort of the conductor of the entire experience. But with async and defer, we tell it it's OK to do the parsing and everything separately. Like, get that out of the way so that people can still interact with the page. And then only when you're ready to run it, then move it onto the main thread. So it speeds that up as well. Async and defer actually also protects against some fragility introduced by a single point of failure, which I think is one of those performance topics that just never, I don't know, it's just never seemed to get as much attention as it should. Single point of failure is a situation where you're using a third-party resource, and the third-party domain that you're loading it from has issues. Like their site suffers, they've got some server issues, IP issues, something that is causing them to be slow to respond. And because of that, because of the blocking nature of JavaScript, when they suffer, you suffer as well. It's a pretty common situation, and it can impact both the browser experience as well as the search engine indexing experience. Catchpoint just wrote a blog post about something they saw on Black Friday. We're probably the worst time for a third-party provider to ever go down if you're an e-com company, right? But they found out, they were looking at some data, and what they saw was that Core Metrics, which is a really popular service used by e-com sites, had a little bit of issues. You can see here's a chart of the response time to the data.coremetrics.com site. Right? So things are going well here until around 9:15. All of a sudden, you see the response time from that domain spikes. We're talking up to 30 seconds to get a response from the domain. If you look at the chart for the performance of the sites using that same script, it matches up. Once they get to that same spike, because Core Metrics was coming in late and because Core Metrics was being loaded in a blocking way, we have page load times that are jumping up to 35 seconds. And it's all because of their dependency on that one third party. And if that third party is async or defer, you don't have that issue. But instead, we've stopped the parsing of everything and waited 30 seconds for core metrics to come through. And I'm not picking on core metrics. Like, this is not just them. This is the reality of the web. Things are going to break. Your third-party services are going to have outages. They're going to have issues. At some point or another, this will happen. It's also a geography thing. Single point of failure is a huge thing if you're trying to reach any sort of a global audience, particularly somewhere in China. With the whole Great Firewall of China, like SPOFs are extremely common in that kind of situation. So async and defer are deceptively simple. They're just 5 characters, 1, 2, 3, yeah, 5 characters each, but they can actually be extremely impactful from a performance perspective and a usability perspective. Now, this helps with when the execution happens, but you still have to deal with the fact that we have a lot of execution and a lot of script to deal with. We were talking about that 457 at the median for desktop. That's the compressed small version. When we send text resources over the network, we package it up in a nice tidy bundle and just compress it really tight. And when it gets down to the browser has to unpack it and deal with all that raw text. So what this means is that, yeah, we're sending 457K over the network. When the browser gets that JavaScript, that's anywhere between 2,500 to 3,000 kilobytes of JavaScript code that it has to run through, parse, compile, and then eventually execute. I just want to put this in perspective. Anybody play Doom? OK, Doom, the entire code base, 2,300 kilobytes. So we are sending more JavaScript to power a single web page than was needed for the entire code base to create what is pretty much a classic epic video game. I think we can all agree. So I just wanted to put that in perspective. Now, I don't want to make it all sound gloom and doom. I'm so sorry. I amuse myself. Yeah, I know, I'm bad. This is why my wife never hangs out with me in public. It's the dad joke thing. However, the parse and compile time for this can be very significant as well. Adi Osmani from Google fired up a bunch of tests trying to see for like 1 megabyte, so less than what we're loading at the median, how long does it take to just do the parse part? Ignore the execution, just for the browser to figure out what it's going to do across a bunch of different devices. And these are the results. You see at the top, the MacBook Pro is not too bad. But as you start to get into that long tail of devices, those mid to low-end Android devices, which, by the way, are what are powering the growth of the web right now, then you're jumping into the 3,000, 4,000, 5,000, 6,000 milliseconds to parse 1 megabyte. So when we're passing potentially 3,000 kilobytes down, we're talking just from a parsing cost, like 9,000, 10 seconds, 11 seconds is not atypical to run across. So there's a significant cost associated with all this JavaScript. And one of the most important things we can do is send a lot less down. One of the great tools for identifying this and seeing if you have code, because there's usually a lot of excess code that isn't being used that's being sent down to the device, is to fire up the Chrome dev tools. I know Sean mentioned like keeping them open just to make yourself look productive. I'm one of those weirdos who have it open anyway. Like, I literally do browse all day with this open. But inside there's this fantastic code coverage tool. And what this will do is it'll load the page and track all the code that's being used and not used for every single JavaScript and CSS file. So you can zero in and see, all right, cool, on this particular JavaScript file, 80% of that code isn't being used during the page load process. Even better, you can pull it up inside the source panel, and it will actually highlight the blocks of the code that is not being used on the page. So you can go through this and very quickly identify entire functions, entire plugins, entire frameworks that maybe are there from a legacy perspective, or maybe like are used on certain pages but not on others. And you can start to strip those things out and reduce the amount of JavaScript. It's a really, it can be a very impactful process. I did this recently for an e-com site, and in about 2 hours, we had cut 1.5 megabytes of JavaScript out and reduced their time to interactive by like 40%. So you can make some really big gains just from this little optimization here. Again, going back to Dan's research, I did not know he was going to win the research thing, so that's kind of a nice little plug-in. But I was going to, like, offloading this JavaScript altogether from the device. Like, I've been picking on JavaScript a lot. I actually really like JavaScript. I just think we use too much of it, and we use it at the wrong place. We put it all on the browser, on the device, which is the most fragile and the least predictable part of the entire stack. Instead, what we can do is we can start to offload some of that stuff to the server. We can run with the node services in the background, but increasingly to the edge as well on the CDN. For a good example, to sort of add on to Dan's example already, client-side A/B testing, right, is the bane of every performance consultant's existence. It is, you're injecting a script in the page that is going to block the display of the page from a third-party service until it is done manipulating and changing everything. It takes everything that we've talked about so far, like the increased parsing time, the blocking nature, the single point of failure, and wraps it up in one nice disaster of a package. So from a performance perspective, we are not fans of client-side A/B testing. Thankfully, you can kind of start to break away from that. Optimizely, other solutions have server-side solutions. There's also been experimentation pulling this into Cloudflare workers. So Filament Group, which is here in Boston, well, they used to be here in Boston. I think now they're distributed, though some of them remain. They had been doing a lot of experimentation, and they just finally wrote this up a few days ago around putting these A/B tests inside of a Cloudflare worker. And so they built a script. It's available on GitHub. Everything Filament Group does, they put it on GitHub because they're amazing like that. That lets you have this service worker that you can just install in the Cloudflare worker. And it'll parse your HTML. It'll parse the content you send and create the A/B experiment on the CDN level. What that looks like from the HTML perspective is simply comments. You're highlighting a section. In this case, what we're defining is my test, and we have our A and our B within these comments. Then the Cloudflare worker kicks in. It finds the A or the B, siphons it off, and takes the other markup out, and passes that down. So you never end up with the sort of the blocking nature that the client-side stuff works in. You have a very fine-tuned A/B thing, and it's also fairly easy for developers to play with. You wrap a nice GUI on this, it also becomes easier for other folks inside the organization to play with as well. Moving JavaScript off the client is extremely impactful. In fact, moving JavaScript off the client is at the heart of most of the performance improvements that you see whenever you use Google or AMP. It's not Google AMP technically anymore, AMP project. AMP came out with all this to-do about how it was going to make the web much faster. And I had my personal skepticisms from the very beginning, so I wanted to do a little bit of research on this. So I fired up 50 different URLs. I fired up a canonical version, a version built in AMP, and a version built in AMP that is served on the AMP CDN to see what the difference was in performance. And I loaded these up on web page tests through an automated process. And some of the results were pretty interesting. So first off, from a start render perspective, which we talked about as our first clue that something's happening, the canonical version actually beats the AMP version until you put the AMP on the CDN. And we're going to come back to that in a second. So that's the start render perspective. If you look at something like speed index, which is a metric that tries to determine how quickly the page loads, like the majority of the page is painted onto your screen, then AMP beats out canonical. And then again, the CDN gets a huge boost. There were more metrics I looked at, but even from these two, there were like a few interesting questions I thought that popped into mind. First, why is AMP faster? Like, what are they doing that makes them faster in the first place? Why is it slower on the start render? And then why does that get fixed as soon as you start using Google's AMP CDN? So first off, why is AMP faster? You don't have to look very far. Now, AMP is doing some really clever optimizations, some great work, but it's sort of the 80-20 rule here. Like 80% of the game comes from a very obvious place. If you look at those same 50 URLs and you look at the result in terms of the number of requests, the canonical non-AMP version was making on median 318 requests compared to 60 for the AMP version. AMP has a whole set of restrictions around what you can and cannot include in an AMP document. It is possible to shoot yourself in the foot and load a ton of stuff, but they make it much, much harder to do. So from an AMP perspective versus canonical, the AMP ends up with a lot less requests typically. To put this in a little bit more visual perspective, here's a waterfall. This is sort of the heart of all performance thing is a waterfall. If anybody's not seen it, it's showing you every resource that is requested by the page and when it comes in. This is the waterfall for the AMP version of a page. Okay, there's 23 resources on this particular waterfall. This is the waterfall for the non-AMP version of the exact same page with no display differences other than the fact that we have all those third-party stuff coming in. Actually, hold on 1 second, that cut off. Let me just... Is right. We got time, right? It's good. There we go. That's the waterfall for the non-AMP version. And again, visually, there's no difference other than the fact that you have some ads and some like different ad providers and stuff like that. But you jump from 23 requests to 716 requests. You do not have to be a performance consultant or performance engineer to be able to tell that something with 23 resources being loaded is going to be significantly faster than something with 716. You also don't need AMP to necessarily enforce that for you. Now, this is an excessive example. The median thing that we're seeing on the web, if you look through HTTP archive data, is about 59% on any given page is going to be third-party resources versus first-party. That's a number I'd like to see go down. We get a lot of value from these third-party sources, but usually what happens is a lot of times we inject this stuff because we can, and then we don't think about whether or not we're actually using the data. Fixing this is not a technical thing. Fixing this is just sitting down with your marketing team, your other units, and saying, all right, cool, these are the services we're using right now on our page. When's the last time we logged into this one? You know, why do we have 3 different analytics services being called on this? Like making sure that you got real business reason that's driving why these things exist on your page and reducing it can go a long way towards improving performance. So again, AMP does a lot of smart things. This is at the heart of the biggest performance improvement. Why is it slower to start render? Because of this. AMP is very dependent on JavaScript initially to create everything. You don't make an image, you make an AMP image. You don't make a video, you make an AMP video. And it needs custom JavaScript for all of this stuff. And yes, it's asynchronous, but remember, async means that we still have to stop parsing the HTML to execute scripts. So we pause, execute, but then we got another script to execute, another, and another, and another. And so it delays that start render. But it speeds up on the CDN. If you look at what the CDN does, the CDN has a whole series of optimizations it applies. Good stuff that we should be applying anywhere. You can get this from any CDN in a build process, things like restricting your image sizes using HTTP2, injecting some resource hints. But it's the last one that does this. They pre-render the page on the AMP server. They take that JavaScript, pre-render it, and spit out the generated components instead. This is the same thing you hear from search engines with the dynamic rendering and how that can help you, except we're giving that benefit to everyone, not just the user. And again, all of these things you can do without AMP. So for me, AMP is less about a performance decision as it is a business decision. And from a business perspective, we've seen interesting results. We've seen some really good results. We've also seen a few results that were not so good. So you should just be fairly tested. I mean, we've been very data-driven and test-driven this entire day, so I don't think this is a problem. But when you put that out there, make sure you're testing and making sure you're getting the impact you want. You also keep in mind that Google is the primary backer of AMP. It is arguably not a Google project anymore. And in fact, it's a great sign that 25% of the contributors are from Google and the majority are not. However, keep in mind that as of February, 90% of the code is coming from Googlers and 10% is not. I'm not saying this to pick on Google. I just think this is something to keep in mind because in my mind, if we're ever on the fence about what to use, I'm going to bank on the web. And the web's already consuming it. It's taking the best things from AMP, turning them into standards so that you can get things like web packaging, which will let you get your content up in that search carousel that Google loves to tout for the AMP results. Feature policy, which will let you restrict the kind of content that's included on a page. So search engines can use this as some sort of indicator for some reliable means of performance. So if you should use AMP or not comes down to kind of your situation. Not necessarily the performance side of things, but are you willing to maintain 2 versions of your site, and or are you willing to commit to AMP altogether by itself? And if you are, how confident are you sticking around? I'm pretty confident saying the web will be here in 5 years and search engines are going to be indexing it. I can't say with the same degree of confidence that the framework of AMP will be around 5 years from now. When in doubt, bet on the web, which is why I'm more excited about progressive web apps, which is just a fancy way of saying a website with best practices built into it. It gets lumped up with the AMP conversation a lot because I think one of the people involved was a Chrome thing, so it's sort of associated with Google. It's not, though. It's just build a website, make sure it's responsive, make sure it's secure, make sure it's performant, make sure you're doing all of these nice best practices that are very user-focused, and if you do, you got yourself a progressive web app. And where we've seen up and down results of AMP, we've seen amazing results from progressive web apps in terms of what the return is on traffic, on engagement, on revenue, on conversions. We've seen great business impact, and I don't think that's any coincidence. It's powered by the web, directly by the web, and it's very user-focused. And remember, that is our goal. It is to build a better quality experience for our users, for people coming into our sites. It's so easy for everybody, not just developers, not just designers, not just technical SEO people, everybody who's touching it, everybody who's working in technology, it's very easy to forget that what we do is ultimately impacting the lives of real everyday people on the other end. And if we focus on those people and focus on making the improvements that matter to them, that are meaningful to them, we'll cut through the cruft and be able to figure out what optimizations and what improvements actually matter. Thank you.